All right, this is example 2, or actually a variation of example 2 from section 5.2 of your book about substitution as a technique for solving system of equations. What's different from in this example is I added a procedure that's in your book, which mathematicians would call an algorithm. It gives you detailed steps for solving this set of equations. I mean, you could actually take these steps and program it into a computer and have your computer solve this system of equations. And in fact, something like that's already been done many times actually. But in any case, back to the problem at hand. So we're going to go through this systematically, going step by step. Let's just number our equations 1 and 2, and this is our system. Step number 1. So what does step number 1 say? Well, let's call this step number 1. Solve one of the equations for one of the variables. If possible, solve for a variable that has a coefficient of 1 or minus 1. Well, the reason you want to do this is because that's going to make the arithmetic easy, right? Because when we want to solve for that variable, having a coefficient of 1 means 1 times whatever the variable, boom, that disappears. And minus 1 times a variable, well, okay, so I have to change the sign a little bit. That's no big deal. So let's look for a 1 or minus 1, make life easy. Well, that's not a minus 1 coefficient. That's a coefficient of minus 2. Well, that's not a coefficient of 1 either. That's a coefficient of plus 5. That's plus 3. What do we got here? That's implicit 1. So that's what we're going to solve for. And it also tells us we're going to use equation 1, and we're going to solve for x. So we start by copying the equation. X plus 3y equals 5. All right, solve for the equation means I want it to have the form x equals something. All right, so to do that, I'm going to get rid of this. Minus 3y minus 3y. That goes to 0, so I really don't need it. X equals minus 3y plus 5, which is exactly what I wanted. I have solve for x because I have x all by itself over here, so I don't really need to have this twice. Let me erase this mess. And now we're going to move on to step number 2. So what's step? Oh, so we finished number 1, right? Yep. So now let's check number 2. Substitute the expression found in step 1 into the other equation. Okay, we can do that. So this is number 2. What's the other equation? Well, this was equation 1, so the other equation must be equation 2. What was equation 2? Well, it's minus 2x. Well, we're going to substitute, so let's leave a little room to substitute for x plus 5y equals 23. All right, so we're going to substitute this thing on the left-hand side for x because they're equal. They're the same guy. They're the same thing. So I haven't really changed anything. The equality is still going to hold true. Now, what does it say? The equation you obtain should contain only one variable. Oh, guess what? It only has one variable, right? It's got a 3y. It's got a 3y. Oh, check-a-rooney. That is done. So let's do step 3. What is step 3? Solve the equation in step 2. All right, we can do that. First, we got to distribute, get rid of the parentheses. Minus 2 times minus 3y is 6y. Minus 2 times plus 5 is minus 10. Plus 5y equals 23. All right, that's a 10, not a 16. Okay. Now, I got to combine like terms. 6y's plus 5y's are 11y's. You ask me why, I'm such a hairy guy. Okay, so we have 11y minus 10 equals 23. All right, we're solving for y, so let's get rid of the 10 by adding it to both sides. That's 0, leaves us with 11y. 3 plus 0 is 3. 2 plus 1 is 3. So I got 11 times y equals 33. The inverse function of multiplication is division. So I'm going to divide by 11. And if I do it to one side, I have to do it to the other side. Well, that's 1, so that's good. That goes away. 11 goes into 11 once. 11 goes into 33 3 times. So y equals 3. So I solved this. Hooray! So I think I'm done with step 3. Solve the equation. You did? Yeah, I did. I did. So step 3 is done. So now we're looking at step 4. Step 4. Substitute the value you found in step 3 into either of the equations to obtain the value of the other variable. Okay, so I got y equals 3, and I can pick an equation. Can pick 1 or 2. Which one should I do? Well, I like to think of working smart, which is what people do when they're, don't like to do everything the hard way. So if I substitute in here, I got an x, I got a 1x, which means my arithmetic's not going to be so bad. So I'm going to pick this one. Here I have to multiply or divide by minus 2. So I don't want to do that. I'm going to do equation 1. Right? I can do any one I want. So I'm going to do 1. All right. So what am I plugging in? I'm going to plug in y. So let me copy this, leaving space for the y. X plus 3 times y equals 5. And what am I plugging in here? I'm going to plug in my good friend 3. Right in here. Okay, substitute the value found in step 3 in either of the two equations to obtain the value of the other variables. All right, so we got to obtain the value of the other variable. All right, so how do I do that? Well, x, can't do much to that. 3 times 3 is 9 equals 5. I'm going to subtract 9 from both sides. And what do we get? 9 minus 9 is 0. Goes away. X equals 5 minus 9, which is minus 4. All right, so we solve for the other variable. So are we done? No! Even the author says you really should check your values. I like this author. Good idea. So let's check our values. Number 5. Check. So we got to rewrite our equations. Equation number 1. Equation number 1 is x plus 3y equals 5. First equation, x plus 3y equals 5. And what's the second equation? Second equation is minus 2x plus 5y equals 23. Minus 2x plus 5y equals 23. Okay, so now we're going to substitute. X plus 3y equals 5. Or does it? That's the question. So I'm going to substitute minus 4, because that's x, and I substitute 3 here. Minus 4. 3 times 3 is 9. Does that equal 5? Yes, of course. I end up with 5 equals 5. So this equation is true, which means x equals minus 4, y equals 3 is a solution for at least the first equation, but it also has to be a solution for the second equation. So we have to check that one too. Minus 2 times x plus 5 times y, does that equal 23 when I do my substitution? What am I substituting? I'm substituting minus 4 for x, and I'm substituting 3 for y. Minus times a minus is plus. 2 times 4 is 8. 5 times 3 is 15. If I add that up, do I get 23? And of course, the answer is yes. 23 equals 23. So this is true. So this is a solution. And we checked it, and we got to write it as an ordered pair, which is a good idea. So what is our ordered pair? Minus 4, 3. And we're done. Okay? Now, if you think you know how to do this, well, test yourself. Go to the book. Go to page 293. and see if you can do this example. If you can't, you maybe ought to try going through the author's explanation. Perhaps it's better than mine. In any case, good luck.